Now, if the area is instead of, it's not simple enough to be in a table and it's not got an edge that's defined by a function, but instead it's made up of a bunch of little shapes. This is finding the centroid of a composite body or an area made up of smaller sub-areas. And, you might not know this weird shape, but you know a rectangle, you know a circle, and you know a triangle. So what we're going to do is break it up like this, kind of like Tetris or something, where you need to put the shapes together. Now you have to have a perfect match. Okay, this circle, by the way, is a hole. So we have it as a void shape here. So we have a solid rectangle below it, and then we've put a void circle on top and then stuck a triangle onto the side. That's kind of what we're doing here. All right, and we'll go into the process of this in a second. And it'll make more sense when we look at these formulae. These formulae here, x bar is equal to the summation of x tilde sub I times a sub I over the summation of a sub I. This just looks very similar to the calculus that we were just doing, but instead of those fancy integral symbols, now we have summation symbols, which is, they're basically the same thing. One's using calculus and one is not, but it's both summing up things. So here we're going to do this much more discreetly. This is a table-based solution, which you'll see shortly. We need to set an origin, set a datum, we'll call it now, because it doesn't necessarily need to be at the XY origin. It can be anywhere. It can be anywhere you choose. Just make sure you draw it and label it, because then you're going to be referencing it. So if you picked in the bottom left, very common to do, then everything, all of these x tilde sub i's and y tilde sub i's are going to be positive values, but it's going to, it's positive if the centroid is in the positive x from the datum. If we had picked our datum over here to be at the bottom right of this rectangle, the centroid for the rectangle would actually be -8 inches from there. And the circle would also have been a negative. You just got to be very careful with this when you build your tables to put in the negatives where they're appropriate. Void areas, for the areas themselves, void areas go in as negatives, because it's like if you were to get a rectangle, you need to cut out the circle to make it a hole, right? So that's the same thing we're going to be doing here. We're going to be putting in a negative area because we overcounted for it when we said it was a true rectangle. So this is how you would do it. You take the shape and you break it up into shapes that are exactly equal when you add them all together to your original shape. You can't have overlap. You can't have, neglected areas. Voids have to take away by being negative, and you build a table. And the table here is basically your component little areas. And then what are those areas? Again, they're negative if they're void areas. And then you're going to find your x tilde sub I, which is going to be your distance from your datum to the centroid of each of the individual shapes. And then you just multiply the area column times the x tilde column, and you get this column right here. And so if we want to find x bar, we just sum up this column, x tilde sub I, a sub I, and we get a number down at the bottom. And then we sum up our area, and we get a number there, and we just take column 3 divided by column 4 divided by column 2 here, and that would give you your answer, which is pretty nice. Just make sure that you use all of the negatives as they carry through in here, right? And then you would do the same thing again for y, and so here I don't have the area reproduced again because area is just area, right? It doesn't have any effect between x and y, so you're going to use the same first column, but you're now finding your dimensions from your datum to your location of your centroid in the y direction. So you're just repeating the exact same process just with y instead of x. So you're going to take your y values that you find here, multiply them by your areas to get this last column, sum that last column up, take the sum of that column, divide it by your total area, and that would give you your y bar. Easy peasy lemon squeezy. Like I said, you've got to pick a datum, though. It's a reference point. It can be anywhere you want, all right? But you've just got to stick with it. Now, if you put it at the centroid of one of your areas, so like maybe the centroid of the rectangle, So maybe we just picked a datum that was 8 inches in and 9 inches up. The cool thing is this x tilde for your first row and your y tilde for your first row would be 0. So then this multiplication over here would be 0, and it would just add area. It wouldn't add anything into those columns. That's cool, but sometimes then you got to deal with negatives and to get you to other spots. As you do more of these, you get practice, you'll see what would be the easiest. Sometimes you'll have shapes that have, if you pick a datum, it's the centroid of multiple shapes. That's going to be, pretty, you definitely might want to consider using that spot then.